Hello, and today we'll be talking about trigonometry. Trigonometry is a word that originated from the Greek words trigonon, which means triangle, and metron, which means measure. This pretty much sums up the meaning of trigonometry, which is the measure of triangles. But the full definition is the study of triangles and its components, angles and sides, and it's a very important branch of mathematics that helps in studying relationships involving lengths and angles of triangles. Here is a triangle and its sides. Note that there is a 90-degree angle. I've labeled this things A, B, and C, and opposite, adjacent, and hypotenuse. Please note that A and B are interchangeable, and so are opposite and adjacent based on where the angle with the theta is. But C, or the hypotenuse, is always the longest, usually diagonal side of a triangle. So the first step in understanding right triangle trigonometry and trigonometry as a whole is understanding the Pythagorean theorem. The Pythagorean theorem is a relationship among the three sides of a right triangle. It's named after Pythagoras, who was an ancient Greek philosopher / mathematician. It states that the square of the hypotenuse is equal to the sum of the squares of the other two sides, which we can call legs. The Pythagorean formula is simplified in mathematical terms. A squared plus b squared equals c squared. This means that you can find any value of a third side in a right triangle by just knowing the other two sides. Trigonometry introduced a number of functions like sine, abbreviated sin, cosine, abbreviated cos, tangent, abbreviated TAN, cosecant, abbreviated CSC, secant, abbreviated SCC, and cotangent, abbreviated COT. Sine, or SIN, as it's shown abbreviated below, is basically represented as the opposite angle over the hypotenuse. Cosine is represented as the adjacent angle over the hypotenuse. And before I go on, what I mean by opposite and adjacent is that if you see this theta angle right here, this A, or opposite angle, the opposite side, is right across, right opposite to the angle. So that's an easy way of remembering it. And adjacent, well, it's the leg that's right next to this angle. So now that we've got that cleared up, let's go back to tangent, which is A over B, or opposite over adjacent. Or you could also say the sine over the cosine, which is another little trick. And then there's cosecant, which is 1 over the sine, or basically the sine flipped, hypotenuse over opposite. Secant, which is hypotenuse over adjacent instead of adjacent over hypotenuse. It's flip-flopped with cosine. And cotangent, which is 1 over the tangent, or the cosecant over the sine, cosine over the sine. Another trick to remember cotangent. Now you may notice that the bottom three are basically the flipped version of the top three, and we call this a reciprocal, if you didn't know that. It's a nice little term to know in case you want to please your teacher. What else? Also, an easy way to remember the top three, sine, cosine, and tangent, is a nice little acronym, I guess. We call it SOHCAHTOA. So it's a nice little rhyme. Ka and toa kind of rhyme. Even I don't understand it, but it's still nice. So means sine is opposite over hypotenuse. Ka is cosine is adjacent over hypotenuse, and toa is tangent is opposite over adjacent. I find the toa part really helpful because sometimes you'll find that you want to do adjacent over opposite, but it's not. It's opposite angle, opposite side over adjacent side. As for the bottom three, you really don't need to know those at the very beginning. Those will be a little more higher level math, but they're still good to know. Of course, as I just pretty much stated, sin, cosine, and tangent are the most used functions. There's many applications of trigonometry. One is they use it in astronomy to measure the distance between stars. That's of course a little higher level, but this is a stepping stone to getting up there. Two, they use it to measure heights of buildings using the shadow to find the height using the angle. It pretty much looks a lot like this. The height is this A, or opposite, or adjacent actually, in that thing. B is the shadow, and the angle is right here. Also, they use it in geography to measure distance between landmarks and satellite navigation. Another cool little trick involving almost the same thing. They're also used in some periodic table theories and used in many medical, biomedical, and engineering fields. They're using crystallography, I still don't know how to say that, which is the cutting of gems and crystals and stuff. And also, even in music and audio synthesis, which kind of surprised me because that doesn't make sense. But also in seismology, oceanography, and many physical science studies, pretty much kind of like 2 and 3 up here. Same principle. And economic and accounting simulations. Thank you for watching. I hope you enjoyed this video.